I think we can get started now. Okay.
So displacement is vector quantity and distance is scalar quantity.
Displacement is a vector quantity while distance is a scalar quantity. Okay, a physical quantity with which gives both the speed and the direction of the motion of the body is called as
Velocity. Velocity.
velocity. Very good. Okay, a motorcycle has a steady dash of 3 meter per second square. This means that every dash, its dash increases by dash. Okay. Okay, what is this quantity? What is this quantity? 3 meter per second square.
The acceleration.
Okay, when we have a meter per second square, okay, if it was just meter per second, then we can say this represent velocity. But since it is meter per second square, this is acceleration. This means that every every what?
Second.
Every second, its
Speed,
speed, or I think the better word is velocity. So velocity increases by
1 meter. No,
now
wait, sorry, 3 meters, 3 meters
3 meters. What? Just
per
3 meters?
second. No,
3 meters per second.
a second.
Okay. See, velocity unit is meter per second, and acceleration unit is per meter per second square. Okay, so acceleration is nothing but change in velocity. Okay, change in velocity by time. Unit for velocity is meter per second. Unit for time is seconds. Okay, so if you divide meter per second by second, we get meter per second square. So if this acceleration is 3 meter per second square, that means velocity is changing by 3 meter per second every second. Clear? Okay, velocity is the rate of change of, next question. Velocity is rate of change of what?
Displacement. It's
Displacement. Very good.
displacement. And it's measured in m per seconds, I guess.
And
Yeah.
it is measured in meters per second.
Meters
The
per
SI
second.
unit is correct. The SI unit is meters per second.
Yeah.
Acceleration is rate of change of
I guess velocity.
Velocity,
velocity, and it is measured in
meter per second square.
meter per second square. Okay, so please remember this. Acceleration is meter per second square. Okay, what does meter per second square means? It means meter per second every second. Like every second, it's changing by how many meters per second. Therefore, it is meter per second square. Arrange the falling speed in increasing order, keeping least speed first. Okay, this is open ended. Let's see who tells first. An athlete running with a speed of 10 meter per second, a bicycle moving with a speed of 20 meter per minute, a scooter moving with a speed of 30 kilometer per hour.
Yeah.
So you need to just find out which of these three speed is greatest and least. Like you have to arrange them in increasing order, like from least to highest.
Okay, sir.
The only difference is all the three speeds are given in different units, like 10 meter per second, 200 meters per minute, and 30 kilometer per hour. Do you know how to compare these? No? See, for
No.
comparison, it is important that you convert all of them to the same unit. So try to convert the second and the third in meters per second. Okay, try if you can. Okay, a physical quantity.
So will it be the bicycle, scooter, and then the athlete?
So an athlete running with a speed of 10 meter per second. Leave this as 10 meter per second. For the second case, bicycle, it is 200 meters per minute. Okay, so that becomes 200 meter. 1 minute is 60 seconds. Okay, 0 and 0 get cancelled. So this is 10 divided by 6. Sorry, 10 divided by 3 meters per second. Okay, in the third case, it's given 20 kilometer per hour or 30 kilometer per hour. So 30 kilometer per hour. Again, as I said, there are two ways of doing it. Either you can do direct, you can multiply this with 5 by 18 to convert this to meter per second. Okay, so this goes with 3 6 times, or with 6 3 times, and with 6 this is 5 times. So 25 by 3 meters per second. All right. So this is 10 by 3 meters per second, and this is 25 by 3 meters per second. So which is the highest? As we saw that athlete speed was 10 meter per second. A bicycle, when we tried converting that to meter per second, it came around 10 by 3 meter per second, which is nothing but around 3.33.
Yes, sir.
Yes, sir.
So around 3.33 is I think the least, and the third one is 25 by 3, which is around 8.33.
3, 3.
Okay, so that is I think the second highest. So we can say bicycle, then scooter, and then the athlete. A snail covers a distance of 100 meter in 50 hours. Calculate the average distance in kilometer per hour. Okay, so can you help me with the steps? What is the distance in hours, in kilometer? What's the distance in kilometer? For distance, we can use symbol S. Okay, so distance is 100 meter. Do you know how to convert this to kilometer, Tananya? So we divide by 1000, right?
Yeah, by 1,000.
Okay, so 100 divided by 1000. All right, so this is just 0.1 meters. Kilometers, not meters, kilometers. And time in hour is already given in hours, so we can just leave it as 50 hours. Okay, therefore speed is 0.1 kilometer divided by 50 hours. Okay, so this is how much? 1 divided by 50. Zero point 0.1 divided by 50.
So 0.002 kilometers per hour.
0.002 kilometers per hour. Simple. A body travels a distance of 3 kilometers towards east, and then 4 kilometers towards north. Finally 9 kilometers towards east. What is total distance travel, and what is the resultant displacement? Okay, this is a new kind of question. Okay, hopefully you are able to understand. It is traveling east, then north, and then east. So 3 kilometer east, then 4 kilometers north. Okay, then again it goes 9 kilometer east. What is total distance traveled by the body, and what's the total displacement? Sneha, can you at least help me with the first part first, like total distance traveled by the body? In this case, see, what is the definition of distance? Distance is the total length of the path traveled by the body. How much
Yeah.
distance the body actually travels. So can you
Okay.
not tell that from the picture what length the body actually travels?
So you just add all of them.
Yes.
Okay.
Okay,
So
so
16 kilometers.
correct. So here we just add the total distance traveled by the body, like 3 kilometer plus 4 kilometer plus 9 kilometers. So that is 16 kilometers. Okay, I hope all of you understood this. Okay, second part is more tricky. Like second part, they are saying what is the distance traveled by the body? Like sorry, the displacement of the body. Displacement is the shortest length from the starting point till the ending point. Okay, so displacement is the shortest length from the starting to the till the ending point. Okay, I have represented that with a straight line like this. Okay, how do we calculate the straight line? Length of the straight line. Okay, all of you understood the diagram, no? Till here, no problem. And you
Yes,
are
sir.
understanding on the diagram what length we need to find. Let me help you with certain constructions then. See, this length is 9 centimeter, right? From here to here, the red line I've drawn just now. So can I say even this is 9 centimeter? Do you agree with me?
Yes, sir.
Yes, sir.
Okay, and this is 4 centimeter, this length here. So can I say even this is 4 centimeter
Yes, sir.
and this is already 3. So can I say this total length is 9 plus 3, 12 centimeter? Oh, my bad. Kilometer. Please change all my centimeter to kilometer. Okay, that is 12 kilometer.
Yes.
Okay, can I erase these now? Does it now look like a right angle triangle?
Yes.
Do you know how to find hypotenuse length in a right angle triangle?
Yes.
The Pythagoras step.
By Pythagorean theorem. Okay, so we need to find the length AB. So the displacement is nothing but the length AB, and AB is okay. So AB square is equals to 12 square plus 4 square. All right. Okay. 12 square is 144. 4 square is 16. So total is 60, 160. Okay, this is AB square. Because
So
AB,
how did you get
how did I get?
12?
Oh, by doing some construction.
Oh,
Oh, here it was 9 and this was 3. You want me to
yeah.
rewrite that step? 1 second. See, in the original question, it was given that body goes 3 centimeter, okay, towards east, okay, and then it goes 4 towards north, and then 9 towards east. So I shifted this 9 over here because both length looked same to me. And then here there was already a 3 kilometer displacement towards the east in the first part of the journey. So this total length from here to here is 12. Okay, the total base length is 12, and this is 4 because this was 4. Clear?
Yes.
And then later, for better understanding, I erase these lines and just left the right angle triangle where we are applying the Pythagoras theorem to find the value of AB. Since 160 is not a perfect square, I can just write this as the square root of 160. Okay, if you want to simplify this further, 160 root can be written as 16 multiplied with 10. Okay, and square root of 16 is 4, so this is 4 root 10. A boy walks from classroom to the bookshop along a straight corridor towards the north. He covers a distance of 20 meters in 25 seconds to reach the bookshop. After buying a book, he travels the same distance in the same time to reach back in the classroom. Find the average speed and average velocity of the boy. Now, in this question, they're asking us to find average speed. See, we studied this formula. Average speed is defined as total distance by total time. And average velocity is known as total displacement by total time. Okay, so please remember these formulas. Okay, now you need to analyze the situation and see what is total distance and total displacement. See, it covers 20 meter going towards the north and then returns back.
So 20 plus 10, 40.
40, yeah, so
Yeah,
40 meter.
okay.
Then we divide by time, 25, 50 sec. So this is zero point 0.8 meter per second. And what about velocity?
So 0.
0. Okay, so whenever object returns to the same position, displacement is 0 because displacement is the shortest path between starting to the ending point. All right, let's just quickly move to the next question. Okay, this is a good question. A car travels 100 kilometer at a speed of 60 kilometer per hour and returns with a speed of 40 kilometer per hour. Calculate average speed for the whole journey. Okay, I've just written the formula for your help. Average speed is total distance by total time. Okay, I think we need to discuss this together. Anyone who is ready with the answer? We have done
So will
questions.
it 48 kilometers if I'm not wrong?
What is your answer, Vanshika?
So 48.
48 kilometers per hour. Okay,
Then I
will
got 60 kilometers per hour.
Sneha got 60. Okay, we have like
Sir,
variation.
I got 50.
50. 50 is whose?
Mine, sir.
Sneha.
Parishi.
No,
Okay,
sir.
Sneha said 60
Yes, sir. I said 60.
and Parisi said 50 and Vanshika said 48. Okay, so please pay attention. Let's try to do it together. So, as in this case, what happens is this car goes forward and like we'll assume that it's going in a straight line and it returns back in the same straight line. Okay, now it travels 100 kilometer like so the total distance of while going is 100 kilometer, so let's say that distance is 100 kilometer, but it is going at a speed of, okay, so speed of, like I'm writing v here because v means speed, 60 kilometer per hour. Then it returns along the same path, so gain distance is 100 kilometer, but this time velocity is 40 kilometer per hour. Okay, okay, all of you understood till here? See, this is going and then that's coming back, so up is like going and then down is coming back. Okay, for any journey, the total distance, average speed is total distance divided by total speed. What is total distance of journey, like going and coming? What's the total distance?
So 200.
200, right? No problem with that. All of you agree? It's going 100 and coming 100. So total distance is just 200. So we can just write 200 here. But what about total time? Oh, what is total time of the journey?
Sir, I got it as 25 on 6.
25 upon 6. See, this is the tricky part in the question. They have not directly given us total time. So how do we calculate total time? See, while going velocity v1 is 60, while coming velocity v2 is 40. So for such situation, right, you find the time for going separately and time for coming separately. That's the tricky part in this question. So please remember this. If they give you distance and velocity for one part of the journey, and then distance and velocity for the second part of the journey, then need to individually find time for each part of the journey. Time formula is distance divided by velocity, right? Time is distance. Okay, again here I think better we should write distance with s. Okay, distance s. So distance divided by velocity. So 100 kilometer divided by 60. So that is 5 by 3. 5 by 3 hours. And for time too, we do distance divided by velocity again. So this is 5 by 2 hours. Okay, therefore total time t is sum of time t1 plus t2. That means 5 by 3 plus 5 upon 2. Okay, taking LCM, we can say this is 10 plus 15. Okay, can I do that in one step? Okay, so 5 twos are 10, 5 threes are 15, 15 plus 10 by 6. So that is 15 by 6. Okay, so I'll maybe write it together. So the correct answer is 25 over 6. Okay, we add 10 and 15. So I'm putting that value here, total time. So 200 divided by 25 and 6 goes up. So 200 by 25 multiplied with, okay, 6 I can take up. Okay, the denominator goes up. This goes 8 times, and therefore 48 is the correct answer. Okay, a train between Delhi and Agra is 200 km. A train travels first 100 km at a speed of 50 km per hour. How fast must the train travel in the next 100 km so that the average is 70 km for the whole journey? Oh, that's a good question. See here, what happens is the train travel between Delhi to Agra. Now this train is making a stop somewhere in between. So let's say this is a stop. Okay, the total journey is 200 km. The total journey is divided into two parts. First part is 100 km, and the second part is also 100 km, because total journey is 200. So each part is 100 and 100 km. This is like a stop in between. Okay, first part of the journey, they have given us distance, and they have also given us velocity. So here velocity or speed, the speed is 50 km per hour. For the second part of the journey, velocity is 70 km per hour. Oh no, it's not 70 km per hour. We don't know the velocity. This we need to find. And here the distance is 100 km. Okay, and for the for the complete journey, distance is 200 km, while speed is okay. For the complete journey, speed is 70 km per hour. Like the average speed is 70 km per hour. See, if I divide the distance 1 by velocity 1, I would get time for the first part of the journey, right? T1, which is I think 100 divided by 50. Okay, same thing here. If I do speed 2, distance 2 by speed 2, we get time for second part of the journey. Okay, T2. And if I do distance by speed for the third, like the overall journey, I'll get total time for the journey. Okay, so I calculated time for each part of the journey separately. Like this is 10 by 50. So that is nothing but 2 hours. Okay, this we leave it in terms of 100. So 100 by V2. And this is 20 by 7, the total time. Now logically I can say time T1 plus time T2 is equal to total time. All right, because some time is used for first part of the journey and some time is used for the second part of the journey. So total time, which is 20 divided by 7, would be equal to time T1 plus time T2. Okay, simplifying this expression, we can find the value of V. Okay, we can bring this to this side. So 20 by 7, okay, minus 14. Okay, basically minus 2. I'll not skip this step here. Is 100 divided by V2. Okay, let's take LCM and simplify. On taking LCM, this becomes 14 by 7. So 20 minus 14, which is 6 by 7, is equals to 100. And therefore, V2 is equals to 700 divided by 6. Okay, that's your final answer. So 700 divided by 6, you can convert that to decimal form or mixed fraction form. It is 116.66 kilometer per hour. Okay, so all of you understood the concept here, what we did? First, draw the diagram for such questions. Divide the two part of the journey. For each part, check what you have. Like for example, first part we saw that we have displacement, we have velocity. So we calculated time for first part of the journey. Second part, we had displacement, but we did not had velocity. So we just calculated time in terms of velocity. Okay, and for the overall journey also we knew the total distance and the average velocity, so we calculated average total time for the overall journey. Correct? So here this is time for the first part of journey, this is time for second part of the journey, and this is time for overall journey. All of that I am just doing using same formula, distance by velocity, distance by velocity. Okay, so the important part is how well you analyze this problem.
Okay, sir.
Okay, thank you and bye.